All right, guys, so we're going to start our next type of coordinate system, which is going to be polar coordinates and polar functions. So this is going to be a little different than when we graph within the XY plane. We're going to be using rotation and distance from the pole. Okay, so if you want to follow along and take notes in your notebook as we go through these next few videos, please do that. You can pause it at any time. All right, copy down the notes as you see fit. So let's talk about what polar coordinates are. Right. So the system is formed by fixing a point. You can call it point zero or the origin. It's also known as the pole. Right. So we have that point. Then the polar axis is the axis that goes to the right, almost like the same as the positive x-axis in our Cartesian plane. And then the points can be assigned using coordinates r, theta. So what you want to be aware of, so now when we have our two coordinates, we're no longer using x and y, all right, we're using r and theta. And when we get to our functions, we're actually going to see that r is the dependent variable. Theta is the independent variable, where before when we have had x and y, x was the independent, which came first, and then y was the dependent, which came second. So they kind of reverse that here. All right, so let's talk about what r and theta represent, since we're no longer using x and y. So r is the directed distance from the pole to the point. All right. And the reason why it says directed distance is because the sign of r will make a difference. All right. So we'll talk about what happens when r is negative. All right. But when r is positive, we're heading towards the point P. And then theta, as you can imagine, is going to be the directed angle counterclockwise from the polar axis. So again, when we rotate up from the positive x-axis, which in this case is the polar axis, we have a positive theta. If we were going down, we'd have a negative theta. And we're going to use radians when we're talking about the polar coordinate system. We're not going to use degrees. Okay, so just get used to that. So a point, all right, when you're representing it with the coordinates, the r value comes first. That's the distance. And the reason why they call it r is because it's almost like a radius. All right, think of 0 as the center. All right, and then the distance to the point, the shortest distance to the point is the r value. All right, and then theta is the angle. Okay, so if we were trying to plot a point given the polar coordinates, so remember, r comes first, theta comes second. So if we were given this point 2 comma pi over 3, we're basically being told that we're 2 units from the pole at an angle of pi over 3. So a polar coordinate system or polar graph paper looks a little different than regular graph paper. Right. It's actually made up of these concentric circles, and usually there's lines coming out from the origin that represent all the different angles, all right, so that you can plot the points a little bit better. So if we wanted to plot the point 2 comma pi over 3, we'd want to be on this radius 2 circles, because this represents all the points that are exactly 2 units from the pole. And then we'd want to put it at an angle of pi over 3. So we know pi over 3 is 60 degrees. All right, so it'd be roughly around here. Right. So this would be our point 2 comma pi over 3 if we wanted to plot it. Then we could plot another point. Let's say, so this one we've got 3 comma negative 3 pi over 4. So now since we wanted to be 3 units away from the pole, we're going to be on this radius 3 circle. And we're going to revolve negative 3 pi over 4 radians. Okay, so starting at our polar axis, negative 3 pi over 4. So remember, pi over 4 is 45 degrees. So negative 1, 2, 3 pi over 4. All right, and that's how we would plot that point. Okay, if you want to move on to the next video, we will continue.